So in this part we'll talk about the functions and limits in order to reach the part derivative which we need in physics. So what are the functions? A function is defined by y equal fx or y equal gx. Then it's a function of x, and this is what you call a variation of y in terms of the variation of x. So each time x is changing, y is changing. This means for each value of x we can have a value of y. This is what we mean. We have a point having coordinate x and y, and this point belongs to the function, to the curve. And this function can be represented using a graph. It can be a line, a curve, or a circle, and this is according to the equation we obtain. So what are the functions? As a line, it will be of the form y equal fx, means ax plus b. So we notice that the power is 1 or less. This is not passing to the origin. Now y equal ax if it was passing to the origin, or y equals to b where there is no power, means the power is 0. This is where the line will be parallel to the x-axis. Now in the case of a curve, y equal ax to the power n, where n must be bigger than 1. In the case where n is equals to 2, we call this curve parabola. So if n equals to 2, it's called parabola. We'll see what will be the shape of this curve. Now, as for the circle, it will be of the form x squared plus y squared. So we notice here we don't have coefficient, it's 1 the coefficient, minus 2ax minus 2by plus c equals to 0. Example. So what do we have as example? The first one, it's a line. So if you have, for example, y equals 3x plus 2, this is the equation of a line of the form ax plus b, where you can trace this line by taking, for example, 2 points. For x equals to 0, y equals to 2. For x equals to 2, y equals to 8. We put these 2 points on the graph, and then we join this point, we'll have the line. Now, as for the curve, now this form of the curve, it's called parabola. So we notice its equation is of the form x squared. It's ax to the power n, where n is bigger than 1, then it's a curve. But since it's 2 exactly, then this is a parabola. Also, in order to trace it, we can take many points. So here we have 2 points, but in order to trace it, we have to take 3 to 4 points. And then we join the points, and we'll obtain this figure. Now in math, in order to trace the graph, we don't take points. We must do the variation of the table of variation. We continue. Application. So now we'll talk about using the function. So if we have a function called the fx equal to x squared minus 3x minus 1, and the question was calculate y for x equals to 0 and then for x equals to 2. So we'll notice here this is for x equal. This means in order to calculate f of x, what do? We simply substitute the value. So here for x equals to 0, we'll have y equal minus 1 by substitution, and for x equals to 2, we'll have y equals to 1 by substitution. Now if we notice the graph, this is the curve, this is the function fx. So this means that these 2 points having coordinates 0 and minus 1, and 2 and 1 are 2 points belonging to this curve. Now what will happen if, for example, instead of saying for x equals to 0, we say limit when x tends to 0. What do we mean by limits? So when we say limit, this means we are approaching to the function. We are approaching to the value. So a limit tells us the value that function approaches. Okay? So example, instead of saying for x equals to 0, y equal f of 0, we say limit when x tends to 0, for example, or when x tends to 1. This means that x approaches a, or approaches 1 or 0, so according to the value. Now how do we write it? So it's written limit when x tends to a, and it's calculated how? So it's calculated by substitution, by simple substitution. So we notice that the same thing when we want to calculate, it will be the same thing as saying for x equals to 0. We simply substitute the value. This is in which case? In the case where we have limit to a value and not limit to the infinity. So an example, we've taken the same example, but instead of saying calculate fx for x equals to 0, we said calculate limit when x tends to 0 to fx. So in order to calculate it, we write the equation, then simply we substitute x equals to 0. So we have the same method. and it will be minus 1. For the second one, also, we substitute x equals to 2, and we will have, so using the graph, if we notice here, we have the same points, so it's same thing. But the difference is that here, instead of saying for x equals to 2, we say when x tends to 2, means approach 2, then in this case y will approach which point? Will approach the point 1. So we'll have the same point here on the graph. So this is for the limit. We notice that the limit of the value is the same thing as saying substitution of a value.